Class example 2.3.3. This time we are going to write each polynomial in factored form. Now, I know we mentioned this in another class example earlier, but we spent a lot of time expanding. Expanding, we said, was the same thing as multiplying. We also said it was the same thing as determining the product. This time, instead of giving the instruction or the action expanding, we're asking to put it into factored form, or we're going to be factoring, which is the same thing as dividing out common terms. Now, what we want to do in order to make sure that it is in simplest form is we are going to try and factor out the greatest common factor. So we just spent quite a bit of time trying to figure out how to determine the greatest common factor. So let's try and find the greatest common factor for question A between 27r squared s squared, negative 18 r cubed s squared, and negative 36 r s squared. Now the letters I think are a little bit easier. We're just going for the maximum amount of the letters, but the numbers themselves always get a little bit trickier. So usually I put the numbers off to the side here. Okay, so we're going to get 127. It's not even, so I know 2 doesn't work, but 3 times 9 happens to equal to 27, and there's actually no other numbers that go into 27. You can try 4, but it's even, so all the evens are gone. 5 doesn't work. We're up to 7, and that's not going to work either. So we've exhausted our list at 1, 27, 3, and 9. 18 has a few more. I've got 1 and 18. I've got 2 and 9. I've got 3 and 6. Okay, but at least I'm starting to see that 9 in there. So let's hopefully 36 is going to be in there as well. I've got 1 and 36. We've got 2 and 18. We've got 3 and 12. And we have 4 and 9 and 6 and 6. So although 18 is in 2 of these lists, it doesn't matter anymore. I have 3 terms and it has to be common in all 3 terms. So in this particular question here, we can't use 18 as our greatest common factor. Definitely 36 and 27 are out. 12 is not going to be in either of those 2 lists. So we see 9 in all 3 of those lists. So 9 happens to be my greatest common factor so far between the numbers. So I'm just going to write this 9 up here for a second. Then I've got in the first term an r squared, in the second term an r cubed, and the third term only a single r. The maximum amount of r's that I can take out is a single, okay, 1 r. And the s's, I have s squared in the first term, s squared in the second term, and s cubed in the third term, so I'm going to take out an x squared. So our greatest common factor for this term, for this polynomial, happens to equal to 9rs squared. Okay, that's not quite enough. We need to go a little bit further here. We've got this notion of factoring it out. So what we have to do is we actually have to take each one of these terms now, because we are factoring, and divide out those terms. So we're going to go slow for these first 2 examples and see how it goes. So I've got 27r squared s squared. And because I'm factoring and I want this in factored form, I'm going to divide out 9rs squared. Okay. Now when I divide things out, we're going to do with the numbers and then the variables. We've done this in a previous chapter as well. So 27 divided by 9 we know is 3. R squared divided by a single r is only 1 r left over, and s squared divided by itself is equaling to 1, so I'm left with 3r left over. Okay, I'm going to write that 3r up here for now. Next, I'm going to take negative 18r cubed s squared, and I'm going to divide out 9rs squared. Now we see that negative 18 divided by 9 is negative 2. If I have r cubed divided by r, I'm left with r squared. And again, the s squareds cancel each other out, so I'm left with a negative 2r squared left over. Next, I'm going to take negative 36rs squared, and I'm going to divide out 9rs squared. And in this particular case, negative 36 divided by 9 is negative 4. The r's cancel each other out and the s squareds cancel each other out, so I'm left with a negative 4 left over. Okay. Now, we haven't written this in factored form. What we have done so far is found the greatest common factor. Then we divided out the greatest common factor, but these two terms are not equal to each other. Remember that factoring and expanding are opposites of one another. Okay, so when we are thinking about the opposite, what we have done is we have separated our greatest common factor from the rest of our polynomial. So if I was to expand these, then I can actually see the expanding and the factoring should be opposite operations. So if I took 9rs squared and multiplied it by 3r minus 2r squared minus 4, expanding, well, you can use that kind of claw method here. 9 times 3 is 27, r times r is r squared, and I have an s squared tagging along. 9 times negative 2 is negative 18. I have 1r here, 2r's there. That leaves me with 3r's, and the s squared has to just tag along. It's like I'm multiplying it by 1. And 9 times negative 4 is negative 36. I have no r's, no s's on the 4, but I definitely have with the first term. Notice that when I expand it out, I get back to my original polynomial. So if we don't place that 9rs squared there, and we wrote it like this instead, that's not equivalent. That's not the same thing. It's not being multiplied, so they're not the actual same terms. You must be able to put in that rs squared to say that you were factoring out that greatest common factor. Okay, question B. We've got some smaller numbers, so that's good. So let's go a little bit faster here. I know that they're all even, so that's a good start. So the next number up that I can use is a 4. So I can say 4 divides to 4. That's no problem. But unfortunately, 4 doesn't divide into 10. It does divide into 12, but again, it has to go into all 3. So our greatest common factor for the number here is 2, because it evenly divides into 4, 10, and 12. I have an n to the power of 4, and an n cubed, so only one n can be factored out here. I have p squared, a p, and another p, so only one single p. So 2np is what I can factor out. Now, don't forget we're dividing these things. So if I have 4np squared, I'm going to divide out my greatest common factor of 2np. 4 divided by 2 is 2. N's going to cancel each other out. I have 2 p's on the top and 1 on the bottom, so I'm left with a 2p left over. Next, I'm going to take 10n to the power of 4p, and I'm dividing it by my greatest common factor of 2np. 10 divided by 2 is 5. If I have 4 n's on top and 1 on the bottom, I'm left with 3 left over. And the p's cancel each other out, so I'm left with positive 5n cubed. Next, I have negative 12n cubed p, and I'm going to divide that by my greatest common factor. Negative 12 divided by 2 is negative 6. I've got 2 n's left over because 1 cancels each other out, and the p's are gone, so I get minus 6n squared. Okay. I always like to double check and expand this out to make sure that I've actually done this correctly. It is an excellent trick to make sure, especially if you have time, which you do, you're learning at home. Take the time and actually go ahead and expand it out. 2np multiplied by 2p plus 5n cubed minus 6n squared, and expand that out. 2 times 2 is 4. I have no n's, but I see I've got 2 p's. P times p is p squared. 2 times 5, I get 10. I have n and n cubed. That gives me n to the power of 4, and p just tags along. 2 times negative 6 is negative 12. I've got 2 n's here and 1 there, so I get n cubed, and that p tags along. So did I get back to 4np squared plus 10 n to the power of 4p minus 12 n cubed p? I did. So this is our fully factored form. Oops, that's not a very good job.